Hello everyone, welcome to join us in the low temperature thermochronology online lectures. In this chapter 2, I'm going to introduce some basic concepts of thermochronology. I'm Ni Tao from School of Earth Sciences and Resources, China University. And this QR code here will direct you to more resources of this course. There are 3 sections in chapter 2, including 1. Geochronology and radiometric dating. 2. What is closure temperature? And thermochronology basics. First, let's start with going through some key terms in geochronology and radiometric dating. What is geochronology? Geochronology is a branch of geology concerned with the dating of rock formations and geological events. A distinction is made between relative and absolute geochronology, or dating. Relative dating involves the determination of the relative age of, for example, rocks, giving an idea of which deposits in the Earth's crust are younger and which are older, without estimating the length of time that has elapsed since their formation. Therefore, a relative age is the age of the fossil, rock, or geological feature or event defined relative to others. Relative dating is widely used in biostratigraphy, paleontology, and structural geology. Different from relative dating, absolute dating establishes the so-called absolute age of rocks. That is an age expressed in the units of time, usually in millions of years. The term absolute dating has frequently been replaced by the name radiometric dating. The biostratigraphy and paleontology methods, which are based on the study of the fossilized remains of extinct flora and fauna buried in the rock beds. For example here, the lacewing fossils, shell-growing patterns, and tree rings are used for stratigraphic comparison of regions distinct from one another, and the establishment within them of strata of similar age. The similarity of flora and fauna in sedimentary rock beds can be used as an indication that these beds were formed at the same time, that they are of the same age. In structural geology, the principle of superposition is commonly applied for the determination of the relative age of laminated sedimentary rocks as well as volcanic rocks. According to this principle, each overlying stratum is younger than the underlying stratum. The relative age of intrusive rock and other non-laminated geological formations is determined by correlating them to layers of laminated rock. Besides, the relative age of intrusive rock is younger than the respective country rock. As per absolute geochronology, the use of radioactive decay of chemical elements to determine the absolute age of rocks and minerals was proposed in the early 20th century, and the principle has been in use since that time. The decay of radioactive elements takes place at a constant rate, as is expressed within this quotation, where N is the number of radioactive or parent isotope at the present time over a period of time T, and lambda is the decay constant, which we define as the probability that a given isotope would decay per unit of time in relation to the original quantity. Atoms of stable elements, which are no longer decaying and whose amount increases in proportion to the age of the mineral, appear as a result of radioactive decay. In this case, the assumption that the rate of radioactive decay in the history of the Earth has always remained constant is taken to be sufficiently well-founded. Different elements, however, decay at a different rate. The decay of such elements as uranium, thorium, and potassium takes place very slowly over a period of several billion years. These long-lived elements are the ones that are generally used to determine the absolute formation or crystallization age of rocks and minerals. Here, the radioactive elements listed below are bases for distinguished methods of radiometric dating, such as uranium, thorium, lead dating, uranium, thorium, scenario, helium dating, potassium-argon dating, and argon-argon dating. The decay of the naturally occurring radioactive parent isotopes produces some daughter or radiogenic nuclei. Age is measured by the stable radiogenic daughters of radioactive decay of the unstable parent isotopes contained in minerals, as is shown in the two equations here, where NO is the number of atoms of the parent isotope present at the beginning, and E is the natural logarithm base. Daughter products are continuously produced within a mineral as a result of radioactive decay, but may be lost due to thermally activated diffusion. It is therefore important to notice that the relationship expressed by this equation is valid only if the radiometric system is a closed system, where all daughter products are retained as is shown in this cartoon. If not, it is called an open system instead. As is shown in the figure, in a closed system, the number of daughters produced is simply the difference between the initial number of parents and the number remaining after a certain time t. This correlation can be described as D equals NO minus N, where D is the number of non-radioactive daughter isotopes that are formed over a period of time t. The accumulation of products of radioactive decay over a period of time, which is assumed as the base of absolute age determination, is expressed by the formula here. The rate of decay is sometimes expressed as the half-time period, the time at which any quantity of a substance decays by 1/2. In general, there are some atoms of daughter nuclei around to begin with, so a more general expression is this, where DO is the number of daughters original present. Where there are no daughters original present, the age of a mineral can be calculated according to this formula. It should be noted that thermochronometer daughter products are not suitable to be incorporated in the host mineral's crystal lattice. As foreign isotopes, they are therefore mobile and well diffused within the crystal. The concentration of the thermochronological daughter products vary as a result of radioactive decay, as well as via solid-state diffusion. That's all for the first section of Chapter 2. Thank you for your attention.